What actually happens when you die? In the time it takes to watch this sentence, 3 people somewhere in the world have just taken their final breath. By the end of this video, that number will reach nearly 1,000. But what happens in those crucial moments after death? The answer has left even hardened medical professionals question everything they thought they knew about the end of life. In 2018, a young medical student named Sarah was pronounced dead after a cardiac arrest. 2 hours and 45 minutes later, she woke up. Not only was she alive, but she could recall conversations that happened while she was supposedly dead. Her case changed how we understand death itself, but we'll get to that remarkable story later. First, we need to understand what happens in those initial moments when life supposedly ends. The human body is a masterpiece of biological engineering, with 37.2 trillion cells working in perfect harmony. But what happens when the conductor of this vast cellular orchestra, the heart, suddenly stops? The process is more fascinating and far more complex than anyone imagined. Within the first 30 seconds after cardiac arrest, the blood pressure plummets to 0. The skin begins to pale as blood no longer pumped by the heart starts to settle in the lower portions of the body. This process, called livor mortis, creates a marble-like appearance that forensic scientists use to determine time of death. But here's where our story takes its first unexpected turn. The brain, contrary to popular belief, doesn't shut down immediately. In fact, something extraordinary happens. Research from the University of Michigan found that brain activity doesn't just continue, it spikes dramatically. For a brief period, the dying brain becomes more active than it ever was during life. Scientists call this the end-of-life brain surge, and it might explain why so many people who've been revived report vivid experience during clinical death. Let's break down what's happening in those first crucial minutes. Minute 1 to 2, oxygen levels in the brain begin to drop. Pupils become fixed and dilated. Skin begins to take on a waxy appearance. Body temperature starts to decline at approximately 1.5 degrees Fahrenheit per hour. Minutes 2 to 5, the brain's emergency survival systems activate. Glucose reserves are depleted. The end-of-life brain surge occurs. Consciousness, as we understand it, fades. But the most fascinating changes are yet to come. As we move past these initial minutes, the body enters what scientists call the molecular survival mode. This is where death reveals its most surprising secrets. Within the first hour, cells begin their own unique process called apoptosis, programmed cell death. But here's the twist that's revolutionizing our understanding of death. Not all cells die at the same time. Some continue living for days after clinical death is pronounced. Let's look at what survives and for how long. Skin cells, 24 plus hours. Hair follicles, up to 72 hours. Nail tissue, several days. Gut bacteria thrives for multiple days. But what happens at hour 6 is even more remarkable. Remember Sarah, our medical student from the beginning? Her case helped scientists discover something unprecedented about gene activity after death. Research published in Nature Scientific Reports revealed that hundreds of genes actually increase their activity after death. These zombie genes don't just continue working, they become more active than during life. They primarily involve inflammation responses, stress management, cancer prevention mechanisms, embryonic development, cellular survival. This discovery fundamentally changed how we define death. It's no longer seen as a moment, but rather as a process, one that might even be reversible under the right circumstances. By the time we reach 24 hours, the body enters what scientists call autolysis, self-digestion. This process, while seemingly macabre, has provided crucial insights into human biology. Here's what we've learned. 1. Cellular communication. Cells continue to communicate even after the heart stops. 2. Survival mechanisms. Some cells activate emergency survival protocols. 3. Genetic activity. Certain genes become more active to fight cellular death. 4. Microbiome behavior. Gut bacteria enter a unique survival phase. These discoveries have revolutionary implications for medicine. improved organ transplant procedures, new approaches to treating cardiac arrest, better understanding of brain death, advanced preservation techniques, novel therapeutic targets for life-threatening conditions. Let's return to Sarah's case. Her experience, along with others like it, has led to the development of new protocols in emergency medicine. Hospitals are now extending the time they attempt resuscitation, especially in cases of hypothermia-induced cardiac arrest. Some patients have been successfully revived after more than 6 hours of clinical death, completely changing our previous understanding of the point of no return. Today, scientists are using this knowledge to develop new preservation techniques for organ transplantation, treatments for preventing brain damage during cardiac arrest, methods for extending the window for successful resuscitation, understanding of consciousness and its relationship to brain activity. These discoveries raise profound questions about the nature of consciousness and the definition of death itself. If cells can continue living, genes can activate, and the brain can surge with activity after clinical death, when exactly does death occur? The answer, it seems, is far more complex than we ever imagined. Death, as it turns out, isn't a moment. It's a symphony of cellular events, each playing out on its own timeline. Understanding this process isn't just about satisfying scientific curiosity. It's about revolutionizing how we approach emergency medicine, organ donation, and ultimately how we might one day push the boundaries of life itself. Share your thoughts below. What surprised you most about the process of death? And if you could design experiments to learn more about this fascinating transition, what would you study?